Hey guys, Professor Doney here. We're going to try to make up this lecture time we missed by doing some short videos. I'm going to be very brief because I only have 5 minutes in each of these to get through the material. So what we're going to do is look at this problem. The continuation of Chapter 7 is all about having some shortcuts in solving and creating these shear and moment diagrams. You should have seen, if you've been doing the homework, that if we have a whole lot of loading going on top of this beam, that we have to do a lot of different sections, a lot of calculations to get to the drawing, and that can really be kind of tedious and a pain in the butt. So we're going to just look at a couple shortcuts today as we go through this. So I have a problem here. It's a beam. It's simply supported. It's got a pin over here. It's got a roller here. 400, 600, 300 equally spaced at 2 feet apart. Okay? And first thing we want to do is obviously have a free body diagram, which I've just drawn here. And if we go through and let's see if I can do this now. If I go through and sum forces in the x direction, I'm going to find out that AX equals 0, which we've seen before because we don't need anything horizontal as long as it doesn't change. I have to sum force in the y direction. And if I do that, I'll find out that AY equals 675. And if I go through and continue with that, summing moments, possibly about A, I will find that BY is 625. Alright, maybe not in that order. We've seen that sometimes we go through and solve for that sooner or first. And that gives us the key to unlock when we sum moments. Sometimes that gives us the answer quicker, and then we go on to this one to solve that. So anyway, if you're having trouble finding those, you need to go back to support reactions, which is an earlier chapter. So anyway, now we have it. So we have our drawing. Let's put this up here again. We'll put our beam up there. And what we're going to do below it is draw our lines, and for each of the loading we're going to draw some lines because we have learned that things change below loading. So I'm just trying to do this real quick and readable. And what we'll do is have here is the moment, or the shear, sorry, and yikes, we'll have the moment there. Okay, so shear happening and moment happening. Alright, so how does this all work? Well, before, if we want to solve this, we'd do a section, and then we'd have the section go from the left end to X, and we'd find all that. Okay, so the shortcuts, even though this is a fairly simple problem to begin with, the shortcuts work this way. Alright, we have 675 happening at AY, so this starts here at 675. Okay, what we see is, since it doesn't change, there's no changing through that first section, this is going to be a 675 all the way across. Okay? Now what happens, and one of the rules we're going to see, is when there's a concentrated force downwards of 400, we are going to see this section right here drop by that amount. So that's going to be a minus 400 due to that loading right there, and this goes down to 275. And we see it jump down like that. Now, since there's another concentrated force, the 600, we're going to see it jump down by, you guessed it, 600. And that takes us down to a minus 400. I'll put that in there. And then we have a 300 down here, so that's going to jump down another 300, and that makes it, no, it's 275 minus the 600 becomes, what is it, minus 325. Yeah, ignore that 400 there. And then if I jump down another 300, that's going to make this go down to a minus 625 because it jumps down right up here by 300. Okay. Now, does that number work with what we have here? Absolutely. At BY should be 625. That confirms. So there's our shear diagram. As simple as that. Okay. That's pretty nice. Now, what's happening with the moments? Well, since we have a pin at this end, we have to be 0, and since there's a roller at that end, this has to be 0. Alright, and it looks like I have to continue this video in part 2. So hang on, we'll get the next video up here to part 2.